If you ever wanted to build real Solana applications, but you don't know where to start, this series is for you. My name is Benjamin, and in this video we are going to break down one of the fundamental concepts within the Solana ecosystem, Keypairs. This video is part 3 of the complete beginners to advanced series, and we are going to cover what a Solana keypair really is under the hood, how public and private keys work and how they relate to account addresses, and why ED25519 matters. We will then put it into practice by creating new signer keypairs, restoring existing ones, verifying whether a public key is valid and on curve, and confirming that we can actually sign data with our keys. By the end of this video, you will understand authorization and identity, a concept that you will literally use for any transaction on Solana. And with that said, make sure you follow me on X and let's get started. Alright, so before we jump into the actual code, let's have a quick look at what we are going to do. First of all, keypairs, they are an important concept to understand because you will need a valid signature from a keypair or a wallet in order to sign and send transactions on the Solana blockchain. As a side note, Solana keypairs are points on the ED25519 curve, and they consist of a public key and a private key. And the public key becomes the account address, and the private key is used to generate a valid signature for that account. Now, what does it mean to be on the ED25519 curve? It means that a public key has a corresponding private key capable of producing signatures. In contrast, we have, for example, program-derived addresses, which we will also cover later in this course, and they are deterministically derived by programs and intentionally generated off-curve, meaning they do not have a private key and are controlled by program logic instead. We also have associated token accounts, which are standardized PDAs used to hold SPL tokens for a specific wallet and mint. Both PDAs and ATAs will be covered in more detail later in this course. For now, the key takeaway is that Solana keypairs always lie on the ED25519 curve and therefore always have an associated private key. Alright, and with that said, let's jump into the code and create a signer keypair, restore an existing keypair, verify if a keypair is a valid public key and is on curve, verify if we can sign with our own keypair, and eventually create a keypair using the Solana CLI, including a vanity address. Alright, so this is our code base for today, and as you can see, there are many more topics that we are going to cover in this series, so make sure to subscribe so you don't miss any of the other videos. Also, all the code will be available for download via GitHub, and the link for that is in the description. Alright, so for now we are going to look at the index.ts file under Solana Keypairs. And if we click on that, here we can find all the logic that we are going to look at to see if we can create keypairs, restore them, verify, and also see if we can sign with them. Again, we can trigger this file by looking at the package.json file. I also created a script for this file here under Solana Keypairs index.ts. So if we run npm3, it will trigger this file. So back to our index.ts file, what we can do next is open a new terminal, and we can also move that into the editor area, so we can really easy switch between these two. And the first thing that we are going to do is create a random generated keypair using the generate keypair from signer function, which comes with the Solana Kit SDK. And this will create a keypair for us consisting of a private key and a public key. And then we are going to output that as follows. So we're going to say random keypair address, and we're going to output the public key first, as it says here, random signer address, and then we're going to output the whole object containing the private key and the public key. So if we go back to our PowerShell, what we can do is type npm run 3 like this, and that will trigger our script. And as you can see now, here we have that public key that has been generated for us, and then we also have the whole keypair here containing of the private key and the public key, and of course the private key is not extractable. However, we can use this now to sign any transaction in the remainder of this function here. So if we would take this random signer and we have a signature that needs to be signed, we can in theory do that by using this random signer here. So as you can see, we have now created a random keypair containing a public key and a private key, as you can see here, which we can use to sign transactions. Alright, so next we can clear our terminal real quick And then we can look at the next function where we are going to recreate a key pair from a existing private key. And I'm using the private key that we have here into our wallet folder under ID. These are the wallets that we are using. And as a reminder, all the wallets that we are using you can find back in the README file where we have all the information about the project, but also the wallets that we are using in many of the courses within this series. Now for now we are going to recreate the primary wallet. This is the public address, and we have the private key here that we can just copy, and then we can paste that here in the key pair bytes. And then we will turn that into a uint8 array object, and then we can feed that object into the function create key pair signer from bytes. Also, this comes with the Solana SDK, and what this will do is create or restore better the key pair from that private key, and then we are also going to output that just as we did before. And here we are going to mention restored key pair address from uint8 array, and then we're also going to output the public key and once again the whole object containing the key pair. So if we go back to our PowerShell, we can once again run this command npm run 3, and here you can see of course the first random key pair that was created and the restored key pair we can see here. Again, it's pointing to that primary address. So if we copy this and we go to our readme, you can see if we search for that, that is the public address that we just restored by deriving it from our private key here. And you can also see now we have a valid key pair that we can use to sign transactions within the remainder of our script if we want to do so. And it contains a public key, of course, and the private key. So that's what we just did. We derived a key pair from a existing private key that we have here. Now we can do the exact same thing, but instead of using a private key in this format, we can use the base 58 format. Now, in order to do that, we are going to use the function again, create key pair signer from bytes. However, we have to first use a decoder that also comes with Solana Kit. And as you can see here, we are going to encode that base 58 string that we have here, and then that will be turned into the bytes that are required to turn this into a key pair. So what we can do here is also uncomment this, and then you can see that also a wallet is being derived from this base 58 address. Now this is a random address. I just want to show you that you can derive it from both the private key that we have here or a base 58 address. And as you can see here, we have the first random created key pair, then the first restored key pair, and then we have the second restored key pair from that base 58. As you can see, also containing a private key and a public key. So both works, and it depends a bit on how you like to store your private keys, of course. However, you can use this format or this format using the create key pair signer from bytes. If you use the base 58 format, you have to encode it first into the right format to then feed it into this function here. Alright, so let's move on. First of all, we can clear our terminal once again. And maybe we can also comment these console log statements out so we don't clutter up our whole console once we run this once again. Now, the next thing that we want to do real quick is verify if the key pair that has been given to us matches a certain public address. And let's say we have the restored key pair here that we restored or derived from that private key here in the pri.json file. We want to see if that public address matches the one that we have stored, for example, here in the config file. So we're going to store that config file value, which is wallet public key, which is also pointing to that primary wallet. We're going to turn that into a valid address, and address also comes with the Solana Kit. And if we go down a bit once again, you can see that we stored that primary address or that primary public address into this address here, and then we will take this primary public key and we are going to match it against the restored signer public key. It's a really easy and fast way to match these two against each other and make sure that we have the correct key pair derived from the correct private key. Now, if we go back to our PowerShell, what we can do once again is run npm 3, and then you'll see here that it says valid public key. And that just means that the public address that we have at hand in our config file matches the public address of the key pair that we restored from our private key. Alright, so now that we can verify that, let's check out the next thing. And this is where we are going to look if a public address is actually on Curve. Because remember, in certain special cases, for example, these associated token accounts or program-derived addresses, they may not always have a private key associated with them. And we can check this out by looking at the public address and seeing if it is on Curve. And that's what we are going to do here now. Now, for this example, we are going to use both the Web3.js version 1 approach and the Solana Kit approach. And what we are going to do here is have a public key from our primary wallet. Remember this primary wallet that is stored in our config file here that starts with pri. So if we copy this, we are going to turn that into a actual public key, and we're also going to turn that into a address object. So this is imported from Web3.js version 1 and this is imported from Solana Kit. And then next we can uncomment this because we are going to check if both are on Curve. Now with Web3.js version 1 we can just use public key, and then the method that is exposed is called isOnCurve, and then we provide our primary wallet public key address that we created here. And we are going to do the same with the isOfCurve address function from Solana Kit, and also here we are going to provide that address, and this will return to us if that address is or on Curve or is off Curve. We can just once again run npm run 3. This is the valid public key that we were looking at before, and now we can see that this is on Curve, meaning that it has an associated private key, and if it is not off Curve, because this is the opposite. So it's not off Curve and it is on Curve. Now to demonstrate this a bit clearer, what we can do is go to our Solana CLI and start Surfpool really quick. And if we open Studio, once we are in Surfpool Studio, what we can do is airdrop some tokens into our primary account. Remember, we can do that using Surfpool Studio. And if you want to know more about that, we covered that also in the previous 2 videos. So what we're going to do is airdrop some Ray tokens into this wallet. And you will see if we do that, a associated token account will be created. And if we look at this account real quick in a Explorer, so this is our primary wallet, the owner. So if we look at that wallet, you can see that we now have tokens. So these are the Radium tokens, the 100 that we just airdropped into this wallet. Now, if we look at the detailed overview, you can see that we have a token account here, and that is just the account that holds the amount of tokens for our primary wallet. So if we copy this address, this is also a public key, but this should not be on Curve. So if we go back to our PowerShell, or better our index, and we replace this original address here using that associated token account now, or that token account, and we paste that, and then once again run our PowerShell, now you can see that this address is no longer on Curve. You see on Curve false, off Curve true, and that is because this is a associated token account that holds the amount of tokens for our primary wallet. As you can see, also a public address, but not on Curve. In comparison to our actual wallet, this address is on Curve. I hope you understand now what it means to be on Curve. And again, we are going to look at associated token accounts and program-derived addresses and all that stuff later in this series. But for now, you always have to remember that a key pair and the public address from a key pair should always be on Curve. Alright, so finally we are going to check if we can sign with our key pair, because remember, at the end of the day, the purpose of these key pairs and these private keys is to sign transactions, including instructions, and we're also going to look at that once we are going to look at transactions in more detail. But for the purpose of this video, we are going to try to sign a message, and then we are going to verify if this message was signed using that key pair. Now we are going to do that by using the getUFT8 encoder, where we are going to encode a message, and the message says here, "Hello Solana world." So we're going to take that message and turn that into bytes. And then we are going to take these bytes, as you can see here, and we are going to sign these bytes with our restored signer. And the restored signer, remember we did that there earlier, that is the key pair that we derived from the private key that we have here. And that is what we use here, the restored signer keypair private key. And we're going to sign the message that we just turned into bytes. And then we're going to take these signed bytes and produce a signature from it using the getBase58 decoder and then decode these signed bytes. And I'll show you how that looks like by uncommenting this. And then we can go back to PowerShell and run it once again. And then you can see that we have here that original message, the hello Solana world, that we turned into bytes. We have here the signed bytes using our restored key pair, and then the signature here that we decoded using the decode from getBase58 decoder. And that's what you see here. Now, the next thing that we can do is actually verify if this message was signed using this key pair, and we can do that by using the function verify signature. So if we uncomment this, what we are going to do here is provide the public key this time from that restored signer. So not the private key, but the public key. So that's how everyone can actually verify this. These are the signed bytes that we signed with our private key and the original message. And if we give these to that function verify signature, then we can see if this was signed using that key pair that we derived earlier. So what we are going to do now is just output that in our console. So we are going to see if this is true or false. So once again, opening PowerShell, and if we npm run 3, so the message, the signed message, the signature, and then we verified if this signature or that message better was signed using that key pair that we provided the public key from. And it says here true. So we know now that this was actually in fact signed by the restored key pair earlier here, because we verified it with that same public key from that restored signer. Alright, so to finish up this video, I will show you two ways real quick how you can generate these key pairs in a more manual way. Now the first one is by using web crypto, as these key pairs are all crypto key pairs, and we do that by using a seed or generating a seed. Then we are using web crypto, which we import via the crypto library and using the method get random values from that seed. And then from that we are going to create a key pair using the tweet knuckle library using sign key pair from seed, and then we will have a valid key pair. And then we can encode that key pair to a base 58 string, and then we can also output that into our console. And if we do that real quick, so we uncomment this function here, so it will run this. If you then go back to PowerShell, clear our terminal and run npm run 3, you will see that we now have that private key here and also this base 58 format private key. And remember, we can always recreate that key pair from that using this function here that we looked at earlier, the create key pair signer from bytes, using the get base58 encoder, and then provide that base58 string, the one that we just created here within PowerShell. So that is one way that you can create a key pair or a private key that you then can store and then use that later to derive a key pair from. Now another way is using the Solana CLI. So if we open a new terminal here really quick and we open our Solana CLI instead, so we can create these key pairs using the Solana CLI using the Solana keygen command. And this time we are going to do something a bit more fun. We're going to grind for a vanity address, meaning that we're going to create a key pair with a public key that starts or ends with a certain letter combination. So as you can see here, we are going to grind for a key pair that starts with Sol, or this can also be Ben, whatever you like, and we want to create one key pair. Now if we run this, you will see that we will start looking for key pairs that start with Ben, and then it will output that here. As you can see here, now we have also this private key that we can derive a key pair from, just as what we have here with our primary or our secondary account. This is the one that we just created using the Solana CLI grinding for a vanity address. And if we would create this key pair and we would look at the public key, it would start with Ben, because that is exactly what we asked for. Alright, so that's it for today's video. I hope you understand Solana Keypairs a bit better now, as they are used a lot to sign transactions and instructions, and we will see that also in the upcoming videos within this series. In the next video, we are going to deep dive into Solana transactions, so make sure to subscribe so you don't miss any of the upcoming videos. And as a reminder, all the code is always available to download via our GitHub. The link for that will be in the description. And with that said, I hope you thought it was interesting, and I'll see you in the next one.